And we are live.
Sweet.
So does anybody have any questions about the prep?
Negative. And I feel like this is going back to algebra.
Yeah, I know. I was feeling that way. Like, what is x when you like? Are you kidding me right now? Plug in x into this equation. What do you get out? Like, super easy. All right. So question 3, given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept? Y-intercept is also known as like b sub 0, right? So 2.0.
Sorry, what? 2.0, yes.
Okay. And then the slope is 1.5.
Yeah.
And 16 divided by 4 is 4 minus 3 is 1. So I put 1 on question 5.
That sounds good to me.
Okay. 6, if you plot it, it is demonstrating the shape of a hot dog, I guess.
Oh, because you're full?
No, because
Yeah, I'm going to go with a hot dog as well. I guess.
Yeah. I mean, I don't have a better. Yeah. So based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? Should it be this data? These data? I don't know.
It would work. Simple regression would work.
Is appropriate.
Yeah.
Okay. How many observations are in the data?
Is that just how many data points we have?
I'm gonna assume yes.
139?
Yeah.
Okay.
It's an interesting question. Was there anything like that? I don't
I'm kind of confused by that question.
What is the y-intercept? 18.69.
Yep. Slope 12.695. Put 4 in for x, and you get 69.469.
Oh, I forget that the Excel sheet has this little 4 there. Do you get 69.469, you said?
Mm-hmm.
I got
Yep.
the same. Okay, 12. The confidence data results did from student evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? What? Is it talking about the data that we just used?
Yeah, so basically it's saying the x values, like the explanatory variables, are only going to be between 1 and 6.
So if x was 6, what is y? Is that what it's asking?
That's exactly what it's asking. Because it's a positive correlation, meaning that as x gets bigger, y also gets bigger.
So did you get 94.859?
Yeah.
How many explanatory variables are present in simple linear regression?
1.
1.
How many response variables? Also
1.
1. And this is one of those quizzes where it starts borderlining on getting too easy, where I start second guessing myself.
A company in South Dakota manufactured hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, the lengths of the major and minor axes, meaning the company wants to predict size of hat given the circumference. What is the response variable? Size of hat is the response.
Yep.
Because it's the first one. Because it's the variable being predicted. Okay.
Woohoo!
Did you submit?
Yeah, we did good.
Cool.
Now I still feel like a retard for emailing Brother Bennett.
All right. We've been here for 6 minutes, guys.
Let's talk about the project.
Okay. So who is gathering data?
Also, Google search is not random. Ideally, you should use a number generator, not Google, to randomize project approved. We could all collect the data, or Spencer's kind of in charge of data.
Yeah, but Spencer's not here.
So do we want to trade that out and someone else want to take it?
I can take it if need be.
Okay, so are we just going to do what the original design said? Are we just going to take the top 30 cities, look up a shell and a Chevron station in each and compare the prices, or what?
I think that is the way that makes sense to me. It may not be the best way, but I don't know how to do any other way. If we did a number, like a number generator, like what is that it's giving us a number. What does that number represent? Like a city on a list of something? Should we take like make a list of like the 200 most cities and use a number generator for those? You know where I'm coming from?
Yeah.
Wait.
So I'm not entirely sure.
Top 1,000 biggest cities by population in the U.S. So you can find a list that has that.
Okay, and then we could use a number generator to pick from that list.
And then you just go to that city and find a Chevron and a Shell station via Google and do it that way.
I mean, he may not think that Google's the best way, but I'm not sure how else to find access to a Chevron in, say, New York.
Okay, here, Tyler. In the chat on here, I put a link to a website that has like all of that cities I just listed. Everything.
I got it.
Anyway, so if you wanted to do that, if you wanted to do a random number generator, which Google will give you, and do 1 through 1,000, and just I don't know how many data points do we want to take? 30? He said 30 is not the biggest number, but that's the number you need to make sure the sample means are normal.
Yeah, that's what I've been taught the entire.
So like
course.
Him saying that that's not the magic number really confuses me.
Yeah, I don't know why he said that. Let's see. Yeah, does he want us to take more than that? Like,
He talked about QQ plots, but I thought only ANOVA needed a QQ plot. And we're not doing an ANOVA, we're doing a paired sample t-test.
What's the conditions for a paired sample t-test for it to be?
You need simple random sample, which will help if we do a random number generator. And the distribution of the sample needs to be normal, which means you need a sample size of 30 or more.
okay, so what is it exactly that you want me to find? The gas prices between a Shell and a Chevron in the top random 30 cities in the U.S.?
Yeah.
Okay.
Sorry, one more time.
So I'm just clarifying here. You want me, as far as gathering data goes, you want me to randomly select 30 of those U.S. cities, locate a chevron and a shell, and then just get the price of gas from each of those, and then just gather all that data?
Yep.
Okay. I just wanted to make sure that I was on the same page.
And then as soon as you do that, Taylor can do the next part after that.
Okay.
There's a page we have to fill out with the data collection thing, right? On iLearn.
There's a page with both of them, yeah.
Okay.
So collect and describe the data instructions. Begin working on this.
Where's that? What lesson is that in?
So if there's a section called final project.
Oh, okay, there it is.
Well, according to this, we're over 10 minutes. I'm going to stop this broadcast since we're no longer taking the quiz. Is that good with you guys?
Yeah, it's fine.
Fine.
And then there's